All right, in today's notes, we're going to look at what's called the distance formula. And it is a way that we can find the distance between 2 points on a graph. Now let's first look at some examples where we can just count and see how long a line segment is. So on example A here, we can just look and see how far it is between these 2 points. If we start here, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So our line is 11 units long, and we can just count that because it is on a straight line. Same thing for example B. If we start at this point, 6. So it is 6 units long. The trouble is when we get to a diagonal line like this, because we can't just count this way because there's no units showing us how many we can go. So what we need to do is remember the Pythagorean theorem. It's a squared plus b squared equals c squared. And remember, this works for right triangles. If we have a right triangle with sides a, b, and the hypotenuse c, the side lengths always follow this formula. So, because our line segment here is a diagonal line, what we can do is imagine the right triangle formed if we draw in those straight lines out from the endpoints. And we can count those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. This is 11 units tall and 10 units across. And it is a right angle because we have a vertical and a horizontal line there. So we know this is a right triangle. And what we can do now is use the Pythagorean theorem to find the length of this missing side here. So 10 squared plus 11 squared equals c squared. So 100 plus 121 equals c squared, and that's 221. So now we can just take the square root of 221, which is 14.86, and so on. So our missing side length here is 14.87 units. Okay, and this is the whole concept behind the distance formula, that if you have any 2 points on the graph, you can find the distance between them by using the Pythagorean theorem. And so the distance formula, which is this right here, the square root of x1 minus x1, or x2 squared, plus y1 minus y2 squared. What this is it's derived from the Pythagorean theorem. And imagine, in this case, if you have a squared plus b squared equals c squared, and you just want to solve for c. Well, c equals the square root of a squared plus b squared. And if you think of this and this as a and b, that's what this formula is. And so this x1 minus x2 and y1 minus y2, what that is it's finding the distance between these two endpoints. Okay, so if we have an endpoint x1, y1 and x2, y2, the vertical distance between them is y2 minus y1 because that's the difference between the y values, and the horizontal distance is x2 minus x1. And so what you're really doing there is finding the side lengths of those triangles, of the right triangle. Now on this graph we just counted, and we can always do that if we have a graph, is just count. But let's see if we would get the same thing if we knew or just had the endpoints. So this one here is 7, 6, and this one is -3, -5. And so if I want to find the vertical distance, that's the difference in the y values, that's 6 minus -5. That does equal 11. And if I want to find the distance between the x values, the horizontal distance, well, that's 7 minus -3, which is 10. And so yes, you can just count to find those side lengths, or if you don't have a graph, or if your points are inconveniently large, you know, like if it was 32, 47, and negative 100, negative 21, that's a lot to count, but we can just subtract because it's basically the same thing as counting. And so this formula looks very messy, but if you understand where it's coming from, which is the Pythagorean theorem, hopefully it doesn't seem so scary. So let's do some examples here and we can see how it works. Okay, so for example 1a, we have a graph. And so what we can do is simply count. We can just count the distance between each endpoint vertically and horizontally, right? We can draw that triangle. And yes, we could do the math, the subtraction, but honestly, if we have the graph, we might as well make it easy on ourselves and just count. So the distance between these two endpoints vertically is 2, and the horizontal distance is 5. And so we know that 2 squared plus 5 squared equals c squared. And that's 4 plus 25, which is 29. And so the square root of 29 is 5.39. All right, so when you're given a graph like this, it is really easy to just draw the picture. And that's what I would recommend for anyone. If you're given the picture, you know, use it. So for example, B, our vertical distance here is 11 and 8. So 8 squared plus 11 squared, that's 64 plus 121, which is 185. Which gives us a side length of 13.60. Okay, that's what you want to do if you have the picture. Now, if you don't have the picture, if you just have a couple of points, here's where you really want to use the actual formula. So it's the square root. And again, the horizontal distance between the x values is just x2 minus x1 squared, because we want to square each side. And then the distance between the y values squared. And then you add those up and take the square root. So remember, this is the formula. So first what we want to do, and D here stands for distance. When we're looking at it in terms of a picture, yes, we typically use C for A, B, and C for the Pythagorean theorem, but the distance formula, D, is standing for distance. So first what we want to do is find the difference in the x values, which are 6 and 3. So that's 6 minus 3, and then we would square that. Now we find the difference between the y values, and that's 4 minus 2. Then we square that. Okay, so our distance here is the square root of 6 minus 3 is 3, 3 squared is 9, plus 4 minus 2 is 2, squared is 4. So it's the square root of 13, which equals 3.60, or 61. So 3.61 units here on the graph. That's the distance between those points. Let's try it one more time. Remembering the distance formula is the square root of the difference between the x values squared and the difference between the y values squared. Now this formula looks like a lot to memorize, but if you just remember the concept, not so much as the actual things to write in there. It's a little easier. So our x values here are -5 and 0. So -5 minus 0. And the y values are -4 and 8. So -4 minus 8. Okay, so the distance is the square root of -5 minus 0 is -5. And -5 squared is 25 plus -4 minus 8 is -12. -12 squared is 144. So our distance is the square root of 169, which equals 13. Okay, so again, the distance formula looks daunting, looks a little intimidating. But if you think about it in terms of it's just the Pythagorean theorem kind of reduced to its mathematical concept between 2 points, hopefully not so scary, not so difficult or confusing. So if you have a picture, just find the side lengths, right? Draw the triangle, count them up, use the Pythagorean theorem. If you just have 2 points, use the formula. Don't get too caught up in what it looks like. Find the distance between the x values, square it. Find the distance between the y values and square it. Add those together, take the square root.